Welcome back, students. We'll consider the next problems of physics, standard 9. My dear student, first we'll read the problem and try to know what are the quantities which we are given in the problem. First, a kangaroo can jump 2.5 meter vertically. So, given his height is equal to 2.5 meter. What must be the initial velocity of kangaroo? We have to find out initial velocity of kangaroo. Initial velocity is denoted by u, which we have to find. Now here the kangaroo is jumping, okay, and he is jumping in the opposite direction of gravitational force. So acceleration due to gravity g will be minus g is equal to 9.8 meter per second, because the kangaroo is jumping against the gravitational force. When the kangaroo jumps, after some times we know that when a body is raised up in the height, after some times at a particular height the body stop and the final velocity will be what? V is equal to 0. Now here we have relationship between velocity and h. H means what? Displacement. Height can be considered as displacement. Okay, so now we have a relationship between velocity and displacement. So we have one kinematical equation, that is v square is equal to u square plus twice as. We will take the use of this kinematical equation to find out the initial velocity u when the kangaroo jumps 2.5 meter vertically upwards. Here the kangaroo is jumping against the gravitational force, so acceleration due to gravity will be minus. So acceleration due to gravity is denoted by small g and we have mentioned it as negative because the acceleration due to gravity is against the gravitational force. We have a relationship here between velocity and displacement, and we have learned one kinematical equation in which the relation is given by v square is equal to u square plus twice as. But now the kangaroo is jumping against the gravitational force, so acceleration due to gravity will be against the gravitational force. So acceleration will get converted into acceleration due to gravity. That is v square is equal to u square plus twice a will be converted into g, and as the Congo is jumping against the gravitational force, G will be considered as minus G, and here height, okay, will be considered as displacement, and this will be what? Into 2.5. B. What is B here? B is 0 square is equal to U square, because U we have to find, minus is there, so what will be here? Minus twice G's value is what? Into 9.8 into 2.5. We'll take U at the other side of equation, and it will become plus, will become minus. Minus U square is equal to, minus is left, minus twice into 9.8 into 2.5. Minus get cancelled. U square is equal to twice into 9.8 into 2.5. U square is equal to twice into, now we have to remove the digits, so 9.8 into 10. Okay. Into 2.5, we have to remove the digit, into 10. Now what we have done? We have multiplied here 9.8 into 10 and 2.5 into 10. So we have to divide it with the same amount, that is 10 tens are 100. So that there is no change in the value. U square is equal to 2 into, the digit is removed. So 98 into, the digit is removed by multiply by 10, into 25 upon 100. Now we will simplify. 25 ones are 25, 25 fours are 100. 2 ones are 2, 2 twos are 4. 2 ones are 2, 2 fours are 8, 2 nines are 18. So U square is equal to 49. Now U is equal to under root 49. Now U is equal to 7. 7 7 are 49. What is this velocity? What is that initial velocity? So we will write the unit of velocity, meter per second. Therefore, the initial velocity of kangaroo is 7 meter per second. The next example we'll consider. The next example. A motorboat starts from rest and moves with uniform acceleration. If it attains the velocity of 15 meter per second in 5 seconds, calculate acceleration and distance traveled by the boat in that time. Now here we have some values. Meter per second. What is the unit of meter per second? A meter per second is a unit of velocity. So definitely this is a velocity and it is mentioned and it attains the velocity of. So it is clearly mentioned. But still from the unit we can say that meter per second is a unit of velocity and this value is of a velocity. Second, 5 seconds. 5 seconds. Second is a unit of time and the another value which is given is what? Time. But now we have to consider what type of velocity is given in our example. Is it initial velocity or is it final velocity? We have two types of velocity, initial velocity and final velocity. Initial velocity we denote by u and final velocity we denote by v. A motorboat starts from rest initial velocity. So u is equal to 0 and attains the velocity and then after some time attain the velocity. After 5 seconds it attains the velocity. So the final velocity, that is v, is equal to 15 meter per second, is clearly given in our book. And what happened after 5 seconds, after the time interval of 5 seconds, it attains the velocity. When it attains the velocity, it is what? Final velocity. So this value is v. And the body starts from rest, so initial velocity will be 0 and t is 5 seconds. Find the acceleration and also find the distance s. These both we have to find. Now we have one formula. Acceleration is equal to change in velocity with respect to time. A is equal to v is 15, u is 0 and the time interval is 5. So A is equal to 15 by 5. A is equal to 15 by 5. 5 on the 5. 5 3 the 15. So A is equal to 3. What is the unit of acceleration? The unit of acceleration is what? Meter per second square. Now again we have to find out distance. We have again one relationship, that is what? Distance and time relationship. And again, while teaching kinematical equation, I gave you one equation which tells us the relationship between distance and time. That is s is equal to ut plus half at square. Now we will put the value. We will find s is equal to u into what is t? 5 plus half. What is a? Into 3 into what is t? 5 t square. S is equal to 5 into 0, 0, so no need to write. Half into 3 into 5 5 are 25. S is equal to 25 on the 25, 25 2 the 50, 25 3 the 75. We have to divide. 2 3 the 6, 1 5, 2 7 the 14, 1.02, 5 the 10, 0 0. S is equal to 37.5. This distance is what? And the distance unit is what? Meter. Answer. The acceleration of BOAT boat will be, the acceleration of the boat will be 3 meter per second square, and second is what? Distance will be 37.5 meter. The one more example we are going to study. First we'll try to understand the problem. An object of mass 16 kg is moving with certain acceleration of 3 meter per second square. Calculate the force. Find if the same force is applied to the mass of 24 kg, what will be the acceleration? Now, the question is in two parts. In first part, we have to find out force and then use that force to solve the second part of the question. Again, here kg unit is given, so definitely it will be mass. Now here the unit is meter per second square. This is the unit of acceleration, and in this problem clearly it is mentioned acceleration, so no need to have brainstorming. A, we will have mass is given what, 16 kg, and another is what, acceleration, say x is equal to, A is equal to what, 3 meter per second square. Find the force. We have a formula, F is equal to ma. F is equal to 16 into 3. F is equal to 6 3 is 18, 8, 1 carry, 3 1 the 3 plus 1 4, 48 Newton. Now we will see the next part of the question. The next part, what does it calculate the calculate the force. If the same force is applied to the mass of 24 kg, M is given what, 24 kg. Same force means what, F we have find out, that is 48 Newton. Find out the acceleration. A we have to find out. Again we have the formula, F is equal to ma. F we have, that is 48, which we have find out, is equal to the mass is given what, 24, and A we have to find out, so into A. So 48, this will bring back down, dividing, multiplication will go into division, is equal to A. 24 1s are 24, 24 2s are, therefore A is equal to 2. Unit what? Meter per second square. The force will be 48 Newton and the acceleration will be 2 meter per second square. That's all, students. Will stop here. In the next class we will study some new more topic. Thank you.